Hello, in this video I will go over how to integrate powers of tangent and secant. So all you got to remember is when you're working with at least one even number power of secant in in a combination of any powers of tangent, begin by peeling off secant square x and place it next to the dx. And the other thing you need to know is when working at least with one odd number power tangent in combination with any powers of secant, begin peeling off a secant and a tan x, place it next to the dx. Okay, so all you have to remember is if there is a even power of a secant, you take out a secant square x. If there's an odd number power of tangent, you peel off a secant x and a tan x. And then you use your trig identities. Okay, so let's just start with an example. So we got to integrate secant 6x of the square root of tan cube x of dx. What I would do first is, do you see the square root tan cube of x? Maybe I should write it out as a power. So that's what I'm going to do. I'm going to rewrite this as secant 6x, and then I'm going to rewrite the square root of tan cube x, and the dx is outside. I'm going to rewrite this as a power. So how do I write the square root of tan cube x as a power? It's the same thing as tan of 3/2 dx. Okay. Then what you would do is you would factor out, because secant is even, then what you would do is take out a secant square x, right? Because they said that if it's an even, you take out a secant square x and leave it next to the dx. So I'm going to rewrite this as secant 4x, because I took out a secant square x. And then you have the tan 3/2, and then we have an extra secant square x, so I'm going to put it right next to the dx, so it's going to be secant square x dx. Okay, so that's what I did now. I'm going to use one of my trig Pythagorean identities, and I'm going to use the 1 plus tan square x equals to secant square x. So wherever you see secant square x, I'm going to replace it with this. So the secant 4 x, that's like saying secant square x raised to the second power. So I'm going to rewrite this. I'm going to rewrite secant square x as 1 plus tan square x. And then I'm going to raise it to the second power. And then I'm going to leave the tan 3/2 alone. And then I'm just going to leave secant square x alone. Then I'm going to use substitution, and I'm going to say I'm going to set u as tan squared. So I'm going to set u as tan x, and then du would be the derivative of tan x is secant square x dx, right? So I'm going to rewrite this as, so if I say u is tan x, this is going to be 1 plus tan square x would be u squared. And then you still have to raise it to the second power. And then if we say u is tan x, I'm going to replace this tan as u to the 3/2. And then du is secant square x dx. So you could just replace this whole thing with du. Okay. Then what I would do is I'm going to FOIL out the 1 plus u squared raised to the second power. So when I FOIL that out, that's going to be 1 plus 2u squared plus u to the fourth times u to the 3/2 times it by du. Then what I would do is FOIL out this u to the 3/2. So that's what I'm going to do next. So 1 times u to the 3/2 is u to the 3/2. 2u squared times u to the 3/2 is 2u to the 7/2. Because when you're multiplying, you're really adding. So that's like saying 2 plus 3/2. So it's 4 plus 3 is 7. Okay, so that's how I got 7/2. And then the next one is u fourth times u to the 3/2. That is u to the 11/2. And then you solve that du. Then what you do is take the integration of each term. So what's the integration of u to the 3/2? So remember, it's the power plus 1. So what's 3/2 plus 1? That's 1 can be expressed as 2 over 2. So that would be 5/2. So this is u to the 3/2 is going to be u to the 5/2 divided by the power 5/2, which simplifies as 2/5 u to the 5/2. And then do the same thing with 2u to the 7/2. What's the integration of that? Use your integration rule. That would be 1/9 u to the 9/2 plus, and then the integration of u to the 11/2 is 2/13 u to the 13/2 plus c. And then finally, just replace your u with, we said u was tan x. So your final answer is going to be 2/5 tan of 5/2 x plus 1/9, and then u is tan x, so it's tan of 9/2 x plus 2/13, and then u is tan of 13/2 of x plus c. And that's your final answer. Okay, so let's just recap. What I did was secant 6 is an odd even power secant. So if you have an even, you peel off I peeled off a secant square. Okay, let's do another example. So example 2, we have the integration of tan fifth x secant raised to the 1/5 x dx. So what can we do? Since tan fifth, right, tan fifth is technically an odd power, you factor out, you, the rule states if you have a tan that's an odd power, you factor out secant x, tan x, and place it next to the dx. Okay, so that's what I'm going to do. So I'm going to rewrite tan fifth of x as tan fourth of x because I'm factoring out a tan. And then, so if I factor out, okay, so if I factor out a secant x, tan x, right? And I can't really change the problem. So I can't really change it secant 1/5, right? Secant x is to the power 1. So I would have to make this secant negative 4/5 x. Why? Because we still need to get secant of 1/5 x. And if I factor out a secant x tan x, this can't change, but secant of negative 4x times secant of 1x, uh, when you're multiplying powers, you're adding, right? So negative 4/5 plus 1, or 5/5, is 1/5. Okay. Then what we're going to do is, then we're going to do some kind of substitution, and I'm going to use one of your Pythagorean identities. I'm going to use tan square x equals to secant square x minus 1. Okay, so over here we have tan fourth of x, right? Tan fourth of x. We know that tan square x is secant square x minus 1. So I'm going to rewrite this as secant square of x minus 1, and then I'm going to raise it to the second power because I still need a fourth, right? And then I'm going to leave this secant negative 4/5 alone. And I'm going to leave the secant x tan x alone. Okay, and then what I'm going to do is use u substitution. I'm going to set u as secant x. I'm going to set du as secant x tan of x dx. So if I say u is secant x, this would be u square minus 1 square. And then I'm going to say secant to the negative 4/5 x is u to the negative 4/5. And then what I'm going to do is, do you see this secant x tan x? I'm just going to replace that with, or secant x tan x dx. I'm going to replace that with du. Okay. So over here, I'm going to FOIL out the parentheses u squared minus 1 to the second power. So if I FOIL that out, that would be u to the fourth minus 2u squared plus 1 times it by the u to the negative 4/5 du. And then I'm going to FOIL out this negative 4/5. So when I FOIL this out, right, so when I FOIL u to the negative 4, this times by u to the fourth, that would be u to the 16th. And then the next term would be negative 2u to the 6/5 plus u to the negative 4/5 du. And then just integrate each term. So this would be 5/21 u to the 21/5 minus 10 to the 11th u to the 11 fifths plus 5u to the 1/5 plus c. And then lastly, just replace your u with secant. So this is 5 over 21 secant of 21/5 of x minus 10 over 11 secant of 11/5 x plus 5 secant of 1/5 x plus c. And that's it. So yeah, I'm going to stop here, and that is your final answer.